Hey everyone, and welcome. So you've been dealing with integrals for a while now, and you're probably super used to seeing that little plus c at the end of every answer. But what if I told you we could upgrade that? Today, we're jumping into definite integrals, where we go from having a whole family of possible answers to finding one single exact number. Ready to see how it's done? Let's get right into it.
Right, so think about it. You've gotten really good at finding the antiderivative and remembering to stick that plus c on at the end. But in the real world, when you're trying to figure out something like the total area of a plot of land or exactly how far a satellite has traveled, you don't need a formula. You need a number, a final score. So how do we get from a general function to one concrete value?
And this slide just nails the difference perfectly. On one side, you've got the indefinite integral. Think of it like a character creator in a video game, you know? You have your main character template, which is f of x, and that plus c is like all the different skins, outfits, and accessories you can add. It's a whole family of possibilities. But then, the definite integral, that's your final score at the end of a level. It's not a range of possible scores, it's one specific number. That's the whole game.
So what's the main mission here? Why do we even need to find a single number? Well, one of the biggest reasons calculus was even invented was to solve a very old, very tricky problem: how to find the exact area of weird, curvy shapes.
And this is the core idea right here. The definite integral is basically a precision tool. It's designed to find the exact area of that space trapped between a function's graph, the x-axis, and two vertical lines, x equals a and x equals b. These a and b are what we call the limits of integration. You can think of them as the start and end points of the area you're measuring. Now, you might be thinking, oh no, finding this area must involve some super complicated method. And yeah, the official definition is a bit complex. But guess what? We have a superpower that makes it way, way easier. It has a fancy name, the second fundamental theorem of calculus. But honestly, just think of it as the ultimate cheat code for solving these problems. And here it is, the cheat code itself. The formula is actually beautiful, it's so simple. To solve a definite integral, you just follow 3 easy steps. 1, find the antiderivative, which we'll call f of x. 2, plug the upper limit b into that function to get f of b. 3, plug the lower limit a in to get f of a. And for the final step, just subtract them, f of b minus f of a. That's it, seriously. Okay, enough talk, right? Let's actually put this formula to the test with a simple example. We'll walk through it together, step by step, so you can see just how straightforward this is. Trust me, this is much easier than it looks.
All right, here's our challenge. Evaluate the definite integral of 2x from 1 to 3. So our function f of x is 2x, our lower limit a is 1, and our upper limit b is 3. Let's fire up that new superpower.
Let's break this down. Step 1, what's the antiderivative of 2x? Easy. Using the power rule, it's just x squared. So our f of x is x squared. Step 2, now we evaluate f of x at the upper limit, b equals 3. We plug in 3, so f of 3 is 3 squared, which gives us 9. Step 3, let's do the same for the lower limit, a equals 1. f of 1 is 1 squared, which is just 1. And now for the grand finale, step 4, we subtract. We take f of b minus f of a, which for us is 9 minus 1. And the answer is 8. Just 8. A single, clean, beautiful number. No plus c, no x, just 8. And what does this number mean? It's the exact area under the line y equals 2x between the points x equals 1 and x equals 3. How cool is that? Powerful and super precise. You're doing great. Now, the process is simple, but there are a couple of very common traps that a lot of students fall into, especially in an exam. So let's quickly go over them so you can easily spot them and not lose any marks. Okay, trap number 1, automatically adding plus c to your final answer. That's an old habit from indefinite integrals. For definite integrals, you don't need it. Why? Because it always cancels out. If you did f of b plus c minus f of a plus c, the c's would just subtract to 0 anyway. So just leave it out. The second trap is even more common, and that's forgetting to subtract. It's so easy to calculate f of b and feel like you're done. But remember, the formula is a difference. F of b minus f of a. You always have to do that final subtraction. And hey, don't just take my word for it. Your own NCRT textbook makes this crystal clear. It literally says the definite integral has a unique value.
That's the main idea. Not a function, not a bunch of possibilities, but one unique number. So the next time you feel like writing plus C, just remember this line. All right, let's just lock all this in with a super quick recap. If you take away only one thing from this whole explainer, let it be this. This table sums it all up. The indefinite integral, the one with no limits, gives you a whole family of functions, f of x plus c. The definite integral, the one with a little a and b on it, gives you one single number, and you find it using f of b minus f of a. If you can remember this table, you've totally got this. So, you now have this amazing tool, this superpower, to get one exact answer from an integral. So the question I want to leave you with is, what will you measure? It could be anything from the total profit a company makes over a year to the total distance a rocket travels. You now have the tool to find that one exact number. Keep that curiosity going, and I'll see you next time.